These notes are on solving 3 by 3 systems by hand. Uh, so our answers will be in the form of ordered pairs, x, comma, y, comma, z. Let's look at the first one. The first one, they're giving us a gift because for z equals -16, that basically enables us to solve for z right away. So z equals -4. Once I do that, I can then substitute -4 in everywhere else there's a z and solve things. So notice I have x minus 4y plus 12 equals -27, and 2x plus 2y plus 12. Oh, I'm sorry, the first one should be a minus 12. Equals 22. Now, I can turn this into something that we should be pretty good at by now. X minus 4y equals -15, and 2x plus 2y equals 10. That's because I can just subtract 12 over in this problem and add 12 over in this problem. Now I have a 2 by 2 system that I should be pretty good at solving. So I can multiply the top one by 2 or multiply the bottom one multiply the top one by -2 or multiply the bottom one by 2 and end up getting a 2 by 2 system here. So if I leave the top the same and multiply the bottom equation by 2, then I can just add. I get 5x equals 5 and x equals 1. I then substitute that back in, and I get 1 minus 4y equals -15. I subtract the 1 over, I get -4y equals -16, and I figure out that y equals 4. So my final answer is 1, comma 4, comma -5. This is what we call an ordered triple. Ordered triple. So that's an ordered triple. 1, 4, -5. This problem is actually really good for helping us understand what we want to do. So we want to get one of the variables to be gone, and then we can turn it into a 2 by 2 system, which we should be pretty good at solving. Here's problem 2. 2a minus b plus 2c equals 15, -a plus b plus c equals 3, 3a minus b plus 2c equals 18. In a problem like this, they're not giving us something. So what we want to do is we want to find a variable, any variable, that we can eliminate twice. So what I'm going to do is I'm going to look at the first and the second equation, and I'm going to look at the second and the third equation. The reason why I'm looking at those is notice that in the first and the second equation, if I just add them right now, I get rid of the b's. Also notice in the second and third equations, if I add them right now, I get rid of the b's. So if I add both of those, the green pair and the red pair, if I add both of them together, I get rid of the b's. So I'm just going to add the green pair right now. 2a plus -a gives me a. The b's go away. And 2c plus c equals 3c. And that equals 18 because 15 plus 3 is 18. Now I'm going to take a look at the red pair. In the red pair, if I add those straight down, I get 2a, the b's cancel, plus 3c equals 21. Now I have a 2 by 2 system. So the goal is always to try and get 2 by 2 systems because we know how to solve them. So what I did in number 2 here was I got rid of the b's twice. You have to use 2 different pairs of equations to get rid of the same variable. Use 2 different pairs of equations to get rid of the same variable. And now that I've done that, now it's just a matter of doing a 2 by 2 system. So I multiply the top one by -1. I get a, the c's cancel, equals 3. Now I work my way backwards. So I take this 3 and I substitute it into one of the new equations that I just got uh, down here. So I had A plus 3C equals 18, and 2A plus 3C equals 21. I'm going to take this A, substitute it in, take this 3, substitute it in for A, and I can end up solving here. So um, I end up with, I wrote that really weird. That probably won't help many of you. So 3 plus 3C equals 18. Subtract the 3 over and then divide by 3. I get C equals 5. Then I can take both A and C. So I will take A and C and substitute them into one of the original equations so then I can get B. Um, I'm probably going to pick the middle one because B is all by itself and it's positive, and A and C both have coefficients of either 1 or -1. So that's -3 plus B plus 5 equals 3. That's the same thing as B plus 2 equals 3, so B equals 1. So my final answer, written as an ordered triple, I'm going to go in alphabetical order, so A, then B, then C, 3, comma 1, comma 5. Okay, what I want you to do is see if in number 3 you can try to do this problem by uh, setting up a situation where you get rid of the same variable twice, and just you can pick a variety of different ones, um, but just so you know, I will be getting rid of the variable. hmm, let's go with x. So I'm going to get rid of the variable x twice. Uh, that may at least guide you in terms of what our notes are going to look like. So I'm going to pause and then we'll get everything set up. So I've actually set up the situation where you get Y and Z in each of the 3 pairs. You only have to do 2 of them, but I did it in all 3 so you can see whether the 2 that you picked, you got the correct equations. Now I could do any 2 combinations of these 3 things and end up getting the right answer. So it just totally depends on the way that you want to do it. You also could have got rid of a different variable. You could have got rid of Y. Y might actually be easier to get rid of than X because all you would have to do is take the ones that I have in blue, multiply the middle one by -2. Uh, that gets rid of the Y's. Or you can take the ones I have in green, multiply the top one by 2, that gets rid of the Y's. Or take the ones I have in red and multiply the middle one by 4, that gets rid of the reds. So there are lots of different ways you can do this. What I'm going to do now is I'm going to take the red and the blue equations and do a solving problem because I looked at the green one and I don't really want to deal with the 14 and the 19 and all that other stuff. So what I have here is I'm going to take 5y minus 6z equals -3 and y plus z equals 6. And I'm going to do a little solving. So what I'm going to do is multiply the bottom equation by 6, and I'm just going to replace it. So that's 6y plus 6z equals 36. So 11y equals 33, and y equals 3. Now let's recall that we move back up the chain. So I'm going to take this y, I'm going to substitute it back in to one of these equations. Y equaled 3, so y plus z equals 6. Z also equals 3. So now we're going to move back up the chain and substitute this into one of the original equations with all 3 variables. Since we got rid of x, we're going to get x last. So I'm going to take y equals 3 and z equals 3 and substitute them in. So x minus 3 plus 3 equals 3. Obviously, I picked the middle one because all of the variables have very minimal amounts of numbers in them. So y minus 3 plus 3, I'm sorry, x minus 3 plus 3 means x equals 3. And so it looks like all of the variables equal 3 in this problem. On the back of this sheet, you're going to take notes on how to use the calculator to solve systems of equations using augmented matrices. please do that using the other video with dealing with calculators.